Two teams of scientists journey to Siberia in search of the secret of Tunguska, one of the biggest explosions in recorded history. For 100 years, no one has been able to prove what caused it.
This is like a crime scene. The evidence is there, but we can't find it.
But that may be about to change.
This is exactly the rock that we're looking for.
Looking for evidence of asteroids and signs of ancient volcanoes, whilst fending off the local wildlife. The teams are on Expedition Apocalypse. The village of Vanavara is one of Russia's most far-flung outposts. Here, on a desolate windswept runway, two rival teams of scientists prepare for an expedition even further into the wilderness, to one of the planet's most mysterious places. They must fly in everything they need for the 10-day expedition. Every bit of food, every piece of equipment. One team is Italian and comes laden with sensitive high-tech equipment. The other, made up of an American geologist and his Italian colleague, carries little more than a few pickaxes and a map. But they have a radical new theory about the cause of the strange event. They're heading for a spot 4,000 kilometers east of Moscow, on the edge of the Arctic Circle, where they're determined to solve a mystery that has baffled scientists for over a century. On the morning of the 30th of June, 1908, a massive explosion ripped through the sky above the Tunguska River basin. One shaken eyewitness reported that it split the sky in two. Seismographs hundreds of kilometers away registered a powerful shock. Strange luminescent clouds lit up the skies of Europe for days. 20 years later, the first scientific investigator, Leonid Kulik, reached the remote epicenter.
Kulik was extremely surprised by what he saw. The massive destruction. All of the trees that fell, with their roots pointed in the same direction.
He discovered that the blast had knocked down almost 80 million trees over 2,000 square kilometers without leaving a trace of what caused it. No volcanic ash. No sign of an earthquake. No meteor crater. Nothing. What happened at Tunguska? Today, the leading scientific theory is that an asteroid or comet exploded in the air, vaporizing and leaving no crater. But an airburst of this size has never been seen on Earth. And after 100 years and scores of expeditions, no one has ever proved conclusively what happened that day. Frozen for much of the year, Siberia turns into an insect-infested swamp in the summer, a hostile environment where wolves and bears far outnumber humans.
See here, this map.
Geophysicist Jason Phipps Morgan and his colleague Paolo Vanucci set up camp in cabins built by
I
Kulik.
think the last thing to try to do here. Sleeping in his cabin and then heading out and maybe even finally unraveling the mystery that consumed them for several years of their life. It's a really great feeling.
The investigators are here to prove a theory that the Tunguska blast didn't come from an asteroid.
This was a pretty big tree that it just popped down like a matchstick.
But from the depths of the Earth, in a never-before-witnessed type of natural disaster that could happen again at any moment. For the key to unlock the mystery, Phipps Morgan looks not to 1908, but to 250 million years earlier. He's hunting for proof that an ancient megablast took place here, the great-grandfather of the 1908 event. His quest begins with one of the world's strangest landscapes that just happens to run through Tunguska.
Well, this is a spectacular example of the Siberian traps. And in fact, the name traps means staircase, and you can see a little staircase of steps going up that creek there.
Each step was laid down by a flow of lava that slowly cooled into a super-hard rock called basalt. Over perhaps 100,000 years, lava flowed over Siberia.
It goes down almost a mile in this part, and it stretches sideways about the size of the 48 United States. So this is the biggest outpouring of basalt that is ever known on Earth.
Phipps Morgan suspects in other regions the magma and volcanic gases were able to ooze out of the Earth's crust. But deep beneath Tunguska, the crustal plate was especially thick and trapped magma and volcanic gases. The pressure built until a natural pipe opened up. The gas erupted with a force 100 times greater than the most powerful volcanic eruption known. Then the opening slammed shut. It ejected a column of gas, rocks, smoke, and debris big enough to poison the planet. It's no coincidence, Phipps Morgan points out, that at just this time, 250 million years ago, over 90% of all life on Earth became extinct. The Permian extinction, or Great Dying, has never been fully explained, but Phipps Morgan believes the cause lies here, in the Tunguska mega-explosion. The 1908 event was a much smaller eruption through cracks opened up by the original disaster. It may not be the last.
1908 Tunguska should not be an isolated event. There should be maybe every few hundred years, maybe every few thousand years, there should be more of these explosions happening in this place.
He calls his new kind of eruption a Verne shot, after the science fiction author Jules Verne, who imagined a gas cannon powerful enough to send men into space. So far, the Verne shot explanation has attracted few backers.
We came here with a very simple objective. We want to find a rock to show it was created by a volcanic, Earth-like event to almost 100% probability.
He's after shocked quartz. Quartz that's been exposed to a blast of such high intensity that its entire structure suddenly changes. Until now, we've known of only two forces that can create shocked quartz: a nuclear blast and a meteor impact so powerful it digs a crater in the earth. But Phipps-Morgan is on the trail of a third cause, a Wernshot.
The cross-section here that they draw it coming up.
The investigators have a map created by a previous expedition.
And yet on this mountain we find...
In the vast region of basalt, it shows a ring of sandstone that could contain quartz. Around a mountain close to the epicenter of the 1908 explosion.
It looks on this map.
They just have to find it. And avoid getting eaten by the fearless and wild Siberian bears. During the night, a juvenile entered Phipps-Morgan's cabin. It's got the team on alert.
He's curious, he's hungry, he's stupid, that's the problem. He's not afraid of us.
The scientists set out with an armed guide and specially designed mosquito repellent suits. Exploring Tunguska has never been easy. The first investigators here, Kulik and his team, found themselves in a barren landscape.
Дело в том, что он работал в районе, в котором погибли все.
It was extremely difficult because Kulik was working in the area in the epicenter where all of the animals and plants had died. So there wasn't really anything to eat, and people on the expedition were actually starving. But Kulik was so intrigued that they continued working.
An expedition to Tunguska is still extremely challenging. As they search for sandstone, Jason and Paula have to slog through swampy ground, bushwhacking while fending off swarms of large, hungry mosquitoes. As they walk around the mountain, they find plenty of rocks.
Here.
Yep, some more basalt. Why don't you take a whack at this and just make sure.
But there's no sandstone.
Nothing yet. Okay.
The hunt lasts for 2 grueling days.
Basically, we have covered all of these possible areas, and this map is wrong. Well, this has been pretty frustrating. They have mapped all this orange sandstone all over the place, and here's our mountain with the ring of sandstone, and we are not finding that ring.
No.
I'm pretty sure it's in the area, but it's sort of finding the needle of sandstone in the haystack of Siberian traps.
But Phipps-Morgan is about to make a discovery that could change everything.
This is really amazing.
For 2 days, Jason Phipps-Morgan's hunt for shocked quartz, evidence that the Tunguska blast was caused by a new kind of volcanic explosion called a Wernshot, has been fruitless. Now he throws away his map and heads for the only place around the mountain left to search: the summit. far from the top, the investigators stop at another of Tunguska's strange features. A massive boulder Russian geologists believe was deposited here by an ancient glacier.
So here we are at John's Rock, which is supposed to be a glacial erratic of granite. So why don't we get a sample? Okay, so it has a lot of quartz.
Is it sedimentary rock?
It's not a granite?
No.
It's actually made of the rock they've been trying to find for days. Sandstone, full of quartz.
Okay, sample from John's Rock. Okay. Hey, Paula, come here. Look at this. These are all rounded pebbles. This is not what a glacier does at all.
How does a 5.5-ton rock of sandstone get to the top of a mountain covered entirely by basalt? Phipps Morgan believes it could only have been rocketed here from deep within the earth, carried by a violent vern shot 250 million years ago, the direct ancestor of the Tunguska explosion.
This is what should be a half a mile down. And something punched through and brought it to the surface at John's Rock. This is really amazing.
7 years after proposing his radical theory, he may be holding the proof of a volcanic eruption.
This is exactly the rock that we're looking for.
But he won't know if the quartz contains evidence of a violent shock until he can test it in his lab.
I am extremely excited that we found this. But at the same time that I found that, 20 seconds later, I was busy thinking, how are we going to prove that this really is shocked quartz? And furthermore, is it possible that maybe the tests will fail?
Phipps Morgan will have to wait until he returns home to learn if he has the results he so desperately wants. Eight kilometers from the epicenter, the Italian team is looking for proof that Tunguska was caused not by volcanic gas, but by an exploding asteroid. During the summer, Tunguska's frozen ground melts into a giant swamp. It's far too soft to land safely, so the helicopter hovers a meter or so from the ground while the crew offloads. It's a dangerous maneuver. The 5-member team from the University of Bologna is down safely near their target, a large lake in the middle of the tundra. For the next 10 days, this insect-infested swamp will be their home.
This is a very wild environment with billions of mosquitoes, hungry mosquitoes, so it's very difficult to work in this condition.
This is Carlo Stangelini's first trip to Tunguska, but his team has been here 6 times before. The original expedition leader, Giuseppe Longo, a physicist from the University of Bologna, first came here over 20 years ago, intrigued by the existence of a lake close to the epicenter. In 1999, divers took core samples from a shallow part of the lake, hoping to find microscopic remnants of an asteroid explosion. And the team scanned the bottom of the lake using sonar The images surprise them. They reveal that Lake Cheko is not like other Siberian lakes. It's unusually deep and unusually steep, as if carved by an asteroid. They consulted 19th century Tsarist maps, but found no trace of the lake. Many scientists believe that an asteroid vaporized over Tunguska. That's why there's no crater. But the Italians now suspect this lake was formed by a lone surviving fragment. Proof that an asteroid caused the devastation may have been hiding in plain sight. Now the Italians have returned to Tunguska for evidence. Carlo Stangelini has his first assignment.
Now this is the first time we go out with the camera, so we are trying to film some of the bottom of the lake to see if we can find any tree remains.
With a specially rigged underwater video camera, he's heading out to the center of Lake Cheko, which might be ground zero for the impact of an asteroid fragment. If one destroyed the Tunguska forest here, pieces of trees could still lie on the bottom.
meters. 9 meters. Okay, we are right. Bottom 50 meters.
But something goes wrong. The video camera goes dead, and nothing they do will revive it.
But this was the first try, so this is not a completely unexpected problem. Always arise when you try to do difficult things.
Tunguska has never given up its secrets easily. They will return to shore to fix their camera and try again. And in the meantime, the team will take a different tack. Another member of the Italian team, physicist Romano Serra, is trying a different approach. He's examining the only living witnesses of the event, the trees around the lake, for proof that the lake did not exist before 1908. Serra is a veteran of several previous Tunguska expeditions. He gathers core sections from some trees and slices samples from others.
Benissimo.
10, 20, 30, 40.
The growth rings reveal an unusual pattern. Trees that grow by lakes usually have wide growth rings throughout their life, but these do not. Before 1908, they have very tight rings, typical of trees in deep forest that fiercely compete for light and water. But after 1908, the rings are wider, as though conditions have completely changed. For Serra, the tree's message is clear. In 1908, the forest was replaced by a lake.
I am happy because I have found in 3 rings of the chocolate the confirm of my theory.
It's further confirmation that Lake Cheko is an impact crater. It's simply filled with water from a nearby river. Not everyone is convinced. But the Italians' theory that an asteroid caused the explosion is shared by many other scientists who seek to explain the puzzling evidence the first investigators discovered. When Leonid Kulik mapped the downed trees, he found they lay in a strange butterfly pattern. Two symmetrical wings of destruction, with large, untouched sections in between. Even more confounding, trees still stood in the center, with their branches stripped like telegraph poles. Kulik suspected that a huge meteor fragmented over Tunguska. Yet over 12 years and 4 expeditions, he found no crater, no fragments. Like the Italians, physicist Mark Boslow believes he knows why. The culprit was an asteroid that didn't just split apart. It actually vaporized in what scientists call an airburst. To simulate the Tunguska blast, physicist Mark Boslow harnesses Sandia Labs supercomputers, among the most powerful on the planet. His simulation shows that with an asteroid as tall as a 10-story office building, he can account for every mysterious feature at Tunguska. His nearly real-time animation shows a detailed version of how the airburst might have happened.
It comes into the very thin outer reaches of the atmosphere, but it's moving very, very fast. And it actually is colliding with the molecules of the air and heating them up and pressurizing them and creating this shockwave. Pressure begins to build up, and as it goes deeper and deeper into the atmosphere, eventually the pressure exceeds the forces that are holding that rock or pile of rocks together. As it starts to break apart, its energy of motion is converted to heat, and the entire thing vaporizes, and then that vapor cloud, which looks like a fireball, expands, and that's what creates the explosion, the airburst. The fireball explodes as much as 11 kilometers above the ground, but because of its momentum, it creates a shockwave much more powerful than a shockwave from a similarly sized nuclear blast. At ground zero, it's coming from directly above, so it may strip off the branches of trees, but it doesn't have a horizontal component, so it doesn't actually blow any trees down, and that's why you get these things that the Russian called telegraph poles. And the butterfly pattern of downed trees begins when the shockwave spreads outwards. Boslow's simulation is remarkable and seems complete, but it's all inside a computer. So National Geographic asked impact expert Peter Schultz to test the model by recreating the airburst.
Come on. Let me.
Here we have a forest in Siberia in the middle of an impact chamber. When we have a meteor coming through the atmosphere, will it blast these and level them? Will it embroil them and pick them up? I'm not really sure what's going to happen here.
To simulate the airburst, a gun crew will fire a glass projectile the size of a ball bearing through a thin sheet of mylar. Contact with the mylar should vaporize the glass bead, creating a shockwave that will hit the surface. And to recreate the asteroid's tremendous speed, Schultz will fire a massive vertical gun with a 7-meter-long firing chamber.
Okay. Lock and load. JP, are we set? How does it look? Oh, that's good. That'll give us plenty. Can I do this?
Three meters above the surface, the pellet hits the mylar and vaporizes. But a fireball continues to rocket down, followed by a shockwave, as predicted. The result looks a lot like Tunguska.
Look at this. You see these toothpicks are pointing back. They've all laid down, just like in Tunguska. Almost forms like a heart shape.
The pattern of toppled toothpicks may resemble the downed trees of 1908. But what about the telegraph poles in the center? One toothpick remains upright.
Now we have this tree and actually standing up. It didn't get knocked down like everything else.
The demonstration suggests that an airburst might have created a puzzling destruction found on the ground at Tunguska. Despite their belief that an airburst caused the Tunguska event, Schultz and Boslow don't buy the Italian theory that Lake Checo was formed by a single surviving fragment. They think the asteroid was blown to smithereens.
I don't think it's impossible. It's very unlikely. I can't figure out a way of generating a physical model that explains both the airburst and Lake Checo, but it's possible that I might not have already thought of everything.
But back in Siberia, the mystery deepens. The Italians are about to strike it lucky. On the shores of Lake Checo, the Italian team continues their search to prove the lake is an impact crater. The Russian guides cook up the latest batch of catch of the day and potato soup. Meanwhile, Carlo Stangalini works to repair his video camera. On its first time out, the camera inexplicably failed.
The first hypothesis is that the water came inside from the front glass here. So we are trying to put some silicone where we can and see if it works.
It's June in Siberia, in the midst of what the Russians call the White Night, when the sun never fully sets. After dinner, Carlo heads back out onto the water.
It's almost 10 p.m. and this is a good time to go down with the camera because the lake is very calm.
They believe the deep bottom of the lake contains the remains of a forest, destroyed by a fragment of the Tunguska asteroid.
Meters.
At least it's no, non accendere.
Vuoi sentire che tocchi il fondo?
Sì, certo.
At last, a ghostly image comes into view. Half-buried tree limbs, not just in one place, but seemingly all over. They've been seeking evidence like this for years.
This is what we were looking for. A lot of branches coming out from the lake.
Now the team sets out to haul up samples to bring back to their lab for testing. They send a simple grappling system overboard.
We have to know if these branches are old ones or they are just brought here from the rivers to have an estimate of the age.
These branches may look unimportant, but the scientists hope that they will help clear up the mystery of Tunguska once and for all. But another piece of evidence could make their case airtight. Now Carlo sets out to search for the asteroid fragment that created the lake, the one theorists say shouldn't exist. He's brought a magnetometer, an instrument used to find shipwrecks that detects tiny fluctuations in the magnetic field. Most rocks have tiny bits of metal in them, enough to create a slight magnetic disturbance. If a cosmic body still lies beneath Lake Checo, they hope to detect it.
We are looking for something very deep, and so we need the higher sensitivity as possible.
To avoid interference, they use a rubber raft with little metal. They crisscross the lake, feeding magnetometer and GPS data into a computer to create a magnetic plot.
Visto adesso? Vai. Avanti così.
Back at camp, they study the data and make an intriguing discovery.
Diciamo che questo è strano. C'è questa piccola montagna.
A piccolo montagna, a little mountain. To the scientists, this subtle anomaly is incredibly revealing.
We expect to see a plane, a flat line near the bottom. Instead we saw a bump, a little hill, very U-shaped, that could be a buried item, a buried meteorite.
Final proof of their theory seems so close, but it remains out of reach for now. The Italians return to Bologna, where they'll process their data and plot their return to excavate what may be the long-lost meteor fragment. For the American team too, it's time to go home. Fitzmorgan hopes the rocks he's found will prove his burn shot theory. They leave Tunguska hopeful, but it will be weeks before they'll have the final results. Back in the States, Fitzmorgan tests his samples for shocked quartz. They could prove the blast was just the most recent in a series of recurring burn shots. Volcanic gas eruptions that leave little trace. Normal quartz is unblemished, like this. But a violent shock can rearrange its crystal structure. Phipps Morgan immediately sees what he's looking for. Parallel lines, the telltale signs of shocked quartz.
This is pretty spectacular.
For Phipps Morgan, it's proof that Tunguska was caused by a new type of volcanic blast, more powerful than any ever known.
Conventional wisdom is volcanic eruptions can't make shocked quartz. And I think Tunguska is basically going to be the evidence that convinces people. So to me, this is sort of the smoking gun.
Phipps Morgan believes he's found the first hard evidence of a Verne-shot pipe. 250 million years ago, explosive gases were trapped beneath Tunguska. The pressure built until a crack opened, and all at once the gas escaped, pulling rocks and debris with it.
It's the energy of the world's largest earthquakes concentrated on a single stripe.
Enough, Phipps Morgan believes, to double the carbon content of the atmosphere and explain the mysterious Great Dying, the Permian extinction, when over 90% of all life on Earth vanished. In 1908, the Verne pipe blew again. This time a much smaller blast erupted through old cracks, creating the Tunguska event. But could the asteroid theory also be true? Is it possible that in 1908 an asteroid exploded over the same spot in Tunguska where an ancient Verne shot previously erupted?
Unless you had God playing darts and aiming to keep on hitting the same place on the surface of the Earth, there's no rational explanation why the airburst would have happened over the site of an ancient Verne-shot pipe. This evidence is going to be something that the scientific community needs to try to digest.
Phipps Morgan's theory may finally close the case. But with Tunguska, it seems there is always another angle. At the University of Bologna, the Italian team is working to build its case that a cosmic body caused the explosion. They need to prove beyond a shadow of a doubt that Lake Checo is a recent impact crater. Unfortunately, the tree samples they collected from the lake bottom are too small to date. Luckily, a previous expedition took sediment cores from the bottom of the lake. Marine scientist Luca Gasparini prepares them to be photographed and analyzed.
This is an X-ray image of a core collected from Lake Checo and shows us important things, important details. In particular, we see that this level corresponds to 1908, and we see that above this level and below this level, the sediment look like very different.
The upper level, about a meter thick, contains the fine deposits typical of a stream-fed lake. Just below that point are what the scientists call chaotic deposits. Instead of forming well-defined layers as expected, they are all jumbled as if they were thrown there all at once in a massive explosion. To the Italians, the evidence all adds up. The unusual conical shape of the lake, tree rings, a forest on the lake floor, sediment samples, and the suggestion that a cosmic body lies beneath the lake. They believe it is most likely that in 1908, a massive asteroid vaporized in mid-air. Somehow, one small fragment survived the fiery descent to Earth. Its impact gouged out a crater, creating Lake Checo. And a fragment of the rock may still lie beneath the lake. The Italians intend to return to Tunguska once more to seek the ultimate proof.
I'm sure that people will not be convinced that the lake is an impact crater until we find the remains of this cosmic body. This is exactly what we would like to do.
For over a century, the cause of a Siberian blast as powerful as a nuclear bomb has puzzled scientists. Rival theories still abound. But now, with new evidence, we may be on the verge of finally solving the mystery of Tunguska.
Right now, I think we're at the stage of exciting mysteries.
The fact that it is still a mystery is just fascinating. It says that not all science is easy. Not all the evidence just comes out and hits you in the face. And just hope it's solved before we have another Tunguska, which could be a disaster.